All right, let's go.
Falling jumpers.
78 miles per hour right then. And okay, and then we'll hit the water at 90. They shall hit water at 91 miles per hour. Okay, so they're hitting the water at 91. 78, 91. All right. So I know that we're gonna hit water at 91 miles per hour. Oh my God, it's gonna be a lot of work. All right, so let's dig in. Okay, so what do we have? They got the pendulum move. Okay, so I'm gonna put this to the side. Okay. These guys are doing the pendulum move. All right, so here's the cable. The pendulum move. The connector snaps. And then the splash down. That's it. All right, the final height is gonna be 0. So this is what I got. Initial height is gonna be measured with respect to the final height. So I'm gonna measure everything with respect to the final height. So this is the initial height. Okay, so initial height is gonna be this length, which is 200 feet, plus they drop another 70 feet. So it's gonna be 270 feet. So we got 270 feet. That's the total drop. Ignoring air friction, the only force acting is gonna be gravity. Initial speed is 0. So the question is, what's the final speed? All right, so V is the final speed. So what is it? We want the speed in terms of meters per second, and then convert it to miles per hour. Okay, so we got 270 feet. So I need a conversion for 270 if you have it. I need a conversion for 270 feet. Okay, so it's 82.31. $82.31 meters. That's what we got. Okay, so ignoring gravity, not ignoring gravity, ignoring air friction. We can't ignore gravity. Mechanical energy doesn't change. Initial and final mechanical energies are the same. So assuming that gravity is the only force acting, initial and final mechanical energies are the same. So which means that the equation that we will get to use is this one. That's the only equation we can use. All right, because that's the only equation we can use. Let me check to see if I can use this. Algebra is going to be the same as before. It's the same exact algebra. All right, so algebra is 100% identical. So the speed is going to depend on the height. So what do we have? So it's going to be 2 times g, roughly about 10, times the initial height. So it's going to be 82.32. All right, so multiply and take the square root. I'll give you 40.57. All right, so and then convert it to miles per hour. When you convert it to miles per hour, here's what you end up getting. It's going to be 90.8 miles per hour, roughly 91, roughly around 91 miles per hour. Okay, so here's a question for you. What if these people decided to jump directly into water? What do you think would have happened? So these guys, just pretend that these guys want to directly jump into water. All right, so I'm going to place the water right here. And these guys are just going to hit the water. Okay, how fast do you think they're going to be moving?
91 miles an hour.
How'd you come up with that?
Because it's the same formula. It's all we need is the gravity, the initial height, and since the energies are going to be the same, doesn't matter whether they're doing the pendulum move or not. The energies are going to be conserved, so it's going to be the same either way.
Okay, Jack, give yourself 50 points. Very good point. Because the mechanical energy, if gravity is the only force acting, you get to use the same formula in essence, right? Initial height measured with respect to the lowest point in motion is going to be the same. All right. So if this is 90 miles per hour, this will also be 90 miles per hour. If this is 91, this is going to be 91. What that means is the path of motion doesn't matter, really. The only thing that matters is the initial point and the final points of motion. How you get from this point to that point is not going to matter if gravity is the only force acting. This will take a little bit longer. This is going to take a little bit shorter. All right. If you're in a hurry, take this path. If you want to do sightseeing, take that path. It's not going to matter. Okay. If gravity is the only force acting, mechanical energy is always going to be conserved. Final speed is always going to be the same. The mass doesn't matter. The mass gets canceled out. The only thing that matters is the initial height. The path of motion is not going to matter. That's why it's going to be 91 miles per hour. I put the emphasis here. You know, there's the tension here. And here I said this is motion is unimpeded. So almost intentionally, I created the impression that they're going to be falling faster. I didn't even have to create that impression because your mind was screaming at you. Your mind says, hey, this is right. Your mind, the common sense is just so strong. In terms of your intuitive understanding of reality, your common sense would just lean towards this immediately. So I didn't have to actually force you. You were already here. I say, hey, listen, there's a cable here. So aside from gravity, you got the cable. Cable is impeding the motion, I said. Okay, guys, I got news for you. This thing is going this way, right? Okay, look what the cable does. It's here. The motion is in this direction. And the mass is in this, moving in this direction. The tension is in this direction. Motion is in this direction. The tension is in this direction. Notice that tension is always 90 degrees to motion. So which means that the tension does not contribute to motion. It does not add on to motion. It does not take away from motion. It imparts absolutely no energy to the mass in motion. All right, it just redirects the motion, and that's it. And motion is happening under the influence of gravity. Gravity feeds energy into the system. The tension force is always 90 degrees to motion, so it has zero contribution to motion. The only thing that the tension does is just going to make it longer, in essence. Gravity is going to keep feeding the energy into the system regardless. So that's what's happening. So the path of motion doesn't matter. So the next question is this survivable? Okay, so let's take a look. Will this be survivable? 270 feet drop, right drop.
Blaine says he's trying to convince the city of New York to allow him to jump off the Brooklyn Bridge.
Visually, for me, it would just be so amazing to see somebody falling straight down into that water, knowing the dangers that exist.
That's 135 feet up.
All right, so Brooklyn Bridge, 135 feet up.
A common suicide.
Okay, our distance is 270. It's twice the distance. So would you be able to survive if you were to directly jump into water 270 feet up?
Route.
From 270 feet up.
Beyond 135 feet,
This guy's a medical doctor.
your chances of survival are very slim.
He says, more than likely you won't survive.
No, I won't die.
And he says he won't die.
But how do you know?
Yeah, good question. How does he know? Oh, David Blaine versus a medical doctor.
Blaine says he's trying to convince 5 feet up.
5 feet, 135 feet, your chances of
So medical doctor says it's not survivable.
survival.
But how do you know?
And he says he'll be fine.
Well, make sure of it.
Right? He'll survive. He'll make sure of it.
I'm going to train and
He's going to train and practice. How do you train for something like this? You go like 5 mile running, jogs every single day.
practice and prepare until the
How do you prepare for something like this? All right, guys, try 10 feet, check to see what happens. Increase it to 15, 20, 30. Broken leg, take a break.
point of where I know that, besides wood floating by.
If there's a wood floating by, just wait. Okay, joke aside. Is this survivable? All right, so you got a magician versus a medical doctor. Who do you think knows his physics better? All right, David Blaine, who claims to be an illusionist. He doesn't like the term magician for some reason. He gets really offended by it. He says, I'm an illusionist. He's an illusionist. Versus a real medical doctor who says, it's not survivable. Don't even try it. And David Blaine says, I'll survive that. It's not a big deal. Who do you think knows his physics? A medical doctor or a street magician who thinks he's an illusionist? What do you guys think?
How much did they say the drop was again? Did they say 135 feet?
135 feet, yeah.
I trust David Blaine then.
And our distance is 270 feet. You trust David Blaine? He's just, this guy's confused. He's confused. It's obvious, guys. He's an illusionist. No, he's a street magician who thinks he's an illusionist. What's the difference? I have no idea. All right, so magic is an illusion anyway. So I don't know why he makes. Ayla says, I trust the doctor. That's cute.